Alright, hello once again. Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College AWD, or Application and Website Development Program, and in particular the AWD 1112 Application Programming with Java class, I've been going through a series of video presentations. We will be using two books for the class. The first one is shown on the screen right now. It's Java Quick Syntax Reference. This is a copy of an A-Press book I found as a PDF online. It has 22 chapters in it, and it has a date on it. Well, I don't know. Thought I could find it out, but evidently I don't know where the date is, so it's within the last couple of years. How's that? That said, I've gone through the first 21 chapters in the book, which leaves me with just chapter 22 on generics. I'm going to do that now. And I'm also going to go over chapter 23, which is not in the PDF, unfortunately, but is in the actual book. All right. Now, chapter 22, as you can see, is on generics. Generics, as it says, refer to the use of type parameters, which provide a way to, for lack of better words, allow you to create more general methods, classes, and interfaces, general in that they can operate on different types of data. So the benefits, it says, is they provide compile time type safety, and they eliminate the need for most conversions you might have to do. So as it says, it allows class members to use type parameters. They're defined by adding a type parameter after the class name, which contains a type parameter within angle brackets like this. We've looked at this. We looked at very similar series of, to generics of this in the C# class. The naming convention is typically an uppercase letter. It's usually T for type. Doesn't have to be. When an object of this generic class is instantiated, the type parameter is typically replaced with the actual data type. So notice the T has been replaced with integer. It says as of Java 7, which is fairly recent, a generic class can be instantiated with an empty set of type parameters as long as the compiler can determine the type parameters from or based on the context. So as it says in the example here, this iBox being a new myBox, it says when an instance of myBox is created, each type parameter in the class definition is replaced with or in the type argument. So it behaves as though it was a regular object with a single field of type integer. So notice as it says, this is one of the advantages here. No casting is required when the stored value is set or retrieved from the box field. Also, if the generic field is mistakenly assigned to or set to an incompatible type, the compiler points this out. All right. So notice here we made it a string and tried to work with it as a string. Since it had previously been defined as an int, you can't do that. A method can be made generic, as it says right here, by declaring it with a type parameter section before the return type. Here's an example. The type parameter can then be used as any other type inside of the method. It can also be used as the method's return type, or in a throws clause, and for its parameter type. So again, methods can be declared as generic independent of whether or not the closing class or interface is generic. A generic method, as it says, it's typically invoked just like a non-generic method without specifying the type. In most cases, the compiler is able to infer the type. If this is not the case, you need to specify it. So notice my class print array should be able to be inferred because of the integer, but here it's specifically mentioned. All right. Generic interfaces. As it says here, interfaces interfaces that are declared with type parameters become generic interfaces. It says it has the same two purposes as a regular interface. What is that? Number one is to sort of act like an API or to provide generic methods that any class that implements the interface must declare and implement. All right, and also it can have constants. All right. The passed-in type argument for a generic can either be a class type, an interface type, or another type parameter, but notice it cannot be a primitive type. Generics can have more than one type parameter defined by adding more of them between the angle brackets. This is getting pretty heavy. If a generic has multiple type parameters, the same number needs to be specified when the generic is used. Generics, as it says, are only a compile time construct in Java. Again, meaning they're early binded, meaning that once the program is compiled, the system needs to know what the heck is going on. After the compiler has checked that the types used with generic variables are correct, it then erases all type parameter argument information from the generic code and replaces it with appropriate casts. As it says, generics do not have any performance benefits over non-generic code because of the removed runtime tasks, as they do, for example, in C++. Bounded type parameters, bottom of the page here. It is possible to apply compile time restrictions on the kinds of type parameters that a generic may be used with, known as bounds. They are specified, as it says here, within the type parameter section by using the extends keyword. Notice they can be bounded by either superclass or interface. So here T must be or inherit from superclass A. The second example, it says, specifies an interface of the bound, which restricts the type parameter to only those that implement the specified interface or are the interface type itself. So very similar. Multiple bounds, as mentioned there, can be applied to a type parameter by specifying them in a list separated by ampersands. Aside from restricting the use of a generic to only certain parameter types, another reason for applying bounds is to increase the number of permitted method calls supported by the bounded type. Before generics were introduced back in Java 5, the object type was used to create container classes that basically were generic in nature, in that they could store any type of object. Now that generics are available, the use of the object type should be avoided. It says there because the compiler helps ensure generics are type safe at compile time, which is not done with the object. The collection classes in the Java library, array list among them, have all been replaced with generic versions. Even so, any generic class can still be used. And they show an example of that here. So I've reached the end. But I think what I'm going to do, because the next section in here that's on lambdas is only 1, 2, 3, 4 pages. Let's do this. So this will be kind of a bonus or whatever you'd want to call it. Java lambdas. And I'll just grab this one here. It's in Lambda expression from the Java tutorials. Maybe that's better. And what does it say here? One issue with anonymous classes is that if the implementation of the anonymous class is very simple, the syntax may seem unwieldy or unclear. So suppose you are creating a social network application. You want to create a feature that enables an administrator to perform any kind of action. For example, sending a message. It says the following table describes the use case in detail. So this is what you'd want to do. Suppose that members of this social networking application are represented by a person class. So each person has a sex, probably would be called gender, a birthday, and an email address. So you can get their age, you can print their information. Suppose that the members of your social networking application are stored in a person list, or a list of persons instance. So it says, how would you basically handle this? First way it says is to create methods that search for members that match one of the characteristics. More generic way. Second, create more generalized search methods. Third, specify search criteria code in a local class. 4, specify search criteria code in an anonymous class. 5, and this is what I'm going to talk about, but just for a little bit here, specify search criteria code with a lambda expression. Now, we did look at lambdas last semester. All right, we talked about them. We used them. We used them in conjunction with link queries. All right, so it says here this check person interface is a functional interface defined as any interface that contains only one abstract method. Because a functional interface contains only one abstract method, you can omit the name of that method when you implement it. To do so, rather than using an anonymous class, you use a lambda expression. Something like this. So what are we doing? We're checking for a person who's male and whose age is between 18 and 25. So they've got a thing in here, syntax of lambda expressions, we can look at in just a second. The approach 6, use standard functional interfaces along with these lambda expressions. Approach 7, use lambda expressions throughout the application. All right, so jumping back into the book, which you don't have. Java 8 introduced lambda expressions, which provide a concise way to represent a method using an expression. A lambda expression consists of an argument list, the arrow operator, which is shown, oh, where are you? Again, you've seen this before. There it is. No, it's not. There it is. And a body. All right. The parameter types generally don't need to be specified because the compiler can determine them automatically. A lambda expression is a representation, again, of a functional interface, an interface defining one single abstract method. Therefore, it can be bound to an object such as an interface. We already saw that. Common functional interfaces are defined in the java.util function package. When working on a single operand and returning a value of the same type, you can use what's called the unary operator functional interface. All right, last thing I'll tell you quickly with lambda parameters. Unlike methods, lambda expressions don't belong to any class. They are objects in and of themselves, and they're instances of functional interfaces. A benefit of this is that they provide a convenient way to pass functionality as an argument to another method. You can also achieve this type of functionality by defining an anonymous or unnamed inner class, but it's considerably more verbose. In other words, you're going to write more code. A lambda expression can capture variables from its context, provided that the reference variable is final or effectively final. Finally, behind the scenes, the compiler will instantiate an anonymous class containing a single method to represent a lambda expression. This enables lambdas to be fully backward compatible with earlier versions of the Java runtime environment. That's all I've got from this book. When I come back, which will be quite shortly, I'm going to start writing some Java programs.